Hello, I'm Mr. Franklin, and today we are going to be looking at work in terms of physics. So to start off with, let's start with a definition. Work, one definition for work, is a force applied over a distance. If you want to, you leave a space here. Later we will learn a second definition for work. So we can write work as work equals force times distance. So this is how we mathematically express it. The symbol for work is the capital letter W. So we have force times distance. The unit for work is the joule. J-O, it's an O, U-L-E, the joule. So this is equal to 1 joule. If this was 1 Newton and 1 meter, we would get 1 Newton meter, which is 1 joule. So how do I remember this? I always thought of something silly. We work hard for our money so we can buy some jewels. Okay, that jewelry is spelled different, but it helps me remember that that's the unit for work. Okay, so let's take a look at what does this mean. So I'm going to draw basically a series of cartoon panels. Okay, so I'm going to do actually, you can make yours 4 squares big. It's probably a little easier to see. That first one I drew a little small. And we're going to do 3 panels, 3 sets of 2 panels to talk about work. Okay, so the story is that I have a box, and if the box is sitting on the ground and I try to lift it, okay, I'm going to apply a force. And then as I lift it, I'm going to lift it over a distance, which means I would have done some work. I could take the same box, and instead of lifting it, I could push it. So if I slide the box across, okay, we moved a distance, I would still have work done. Now, if I take this same box and I've already lifted it and I'm just carrying it, so I'm just carrying it, and I carry it over here. I'm just carrying it. The distance the box moved is not in the same direction. It's not in the same direction as the force. So there is no work being done. There's some effort being expended, and if you wanted to look for where actual work in terms of physics is being done, it would be done on the feet acting on the person, but it's not actually being done on the box itself. But it does take effort, but it's not the same thing as work. So when we push the box, it's the force is in the same direction as the distance. When we lift the box, the force is in the same direction as the distance that it travels. And that is when we have work. So pretty simple overall. As long as the force and distance are in the same direction, then we can calculate this. So let's work a 7-step problem real quick, and then I will give you a chance to practice. So our first problem that we're going to do is, let's say Mr. Franklin lifts a box off the ground with an average force of 12 newtons. He lifts it 1.6 meters to the top shelf how much work was done. Okay, so let's follow our process, 7-step problems. First step is R2D2. So we're going to read it. We read it once basically by writing it. Now we're going to do it a second time. Mr. Franklin lifts a box off the ground with an average force of 12 newtons. And that's a force, so we circle and label. He lifts it 1.6 meters. Circle, let's try not to cover up the number there. And that's a distance. How much work was done? W, question mark. Next step is D2. We're going to draw twice. So we're going to draw our picture, and then the second part of drawing is labeling. So I'm lifting a box. So you don't have to draw our full cartoon here. You just draw the stick figure with the box. Force equals 12 newtons, and the distance equals 1.6 meters. Work equals question mark. So I've drawn a picture that tells the story, and I've got my variables labeled with the correct numbers and units. Next part is the guess part, R2D2 guess. So we start with our givens. We are given force equals 12 newtons. Distance equals 1.6 meters. Our unknown is work equals question mark. Our equation is going to be work equals force times distance, which it is on your yellow sheet. You can check it out, but this is the only work equation we have. So now I'm going to substitute. Given a known equation, substitute. And so do I know my force? I don't know work, but I know my force is 12 newtons, and the distance is 1.6 meters. 1.6 meters. I'm running out of room here. I'm going to go ahead and write it here. 1.6 meters. 12 newtons, 1.6 meters. Plug that in your calculator and you're going to get 19.2 capital J joules, and that is our solution. That is our answer. 19.2 joules is the work that I did lifting that box. Okay, so let's do another problem. This one, Mr. Franklin lifts a box with 25 joules of work. He lifts it 2 meters. What is the average force? Okay, R2. Mr. Franklin lifts a box with 25 joules of work. That's work. He lifts it 2 meters. That's a distance. What is the average force? Force average. Okay, so now I'm going to draw a picture. It's amazing how similar these pictures look. Just saying. Okay? Force And don't forget to label. Force equals question mark. Distance equals 2 meters. And the work equals 25 joules. Now we're going to do our given. So that was our D2. So now we're going to do our givens. The D equals 2 meters. Work equals 25 joules. Our unknown is force equals question mark. Our equation is work equals force times distance. And now I'm going to substitute. Do I know my work? Yes, it's 25 joules. What's my force? I don't know, so I write the variable, and then the distance is 2. So I got 25 equals F times 2. So now I'm going to do my algebra. Divide both sides by 2. And F equals 12.5. And that's a force, so that's in newtons. So that's my answer. 12.5 newtons. Okay, so just real quick recap. Please note that work has to be done in the same direction. So if in this example, if it said he walked 2 meters carrying the box, then the work would actually be equal to 0 because the force and the direction would not be in the same direction. Okay, last thing. Quick, I almost forgot to tell you this, but when we do graphs, we will have we'll have force and we'll have distance. And if we have a graph, force and distance, if our equation is work equals force times distance, guess what we are finding? We're finding the area. So the area of a rectangle is length times height, which is force times distance. However, with the triangle, we're finding the average force, so we take our maximum value and take it times a half. And that is the average force, and then we're going to multiply it times the distance. Force times distance. We've been doing this in class, so that should not be new. But now instead of what we've been using with force times time, which is impulse, we are now doing it with work, and it's force and this is distance. So this is a force versus distance graph. Force versus distance graph. Okay? All right. The next video will be about potential energy and its connection to work. Thank you.